Hi, everyone. I hope you had a great break. Welcome back. But I also hope you kept your social distance. All right. So today is Tuesday, April 7th, and we're going to start on our basic right triangle trig and the trig functions, sine, cosine, and all of our old buddies. Also, we'll discuss homework in class and after class. Now, the homework is not due until Thursday, April 9th, midnight. The homework for chapters 2 and 3 only will be due by midnight on Thursday, April 9th. So no trig will be due Thursday. No chapter 4 will be due on Thursday, although I hope you will be keeping up. This is fairly basic trig, but I do hope that you keep up with the homework even through this Thursday. And we'll continue on with chapter 4 on Thursday instead of having a test. This will be a homework due date, but we're going to continue on with chapter 4. We'll continue on with sine, cosine, and those guys, and also talk about their graphs on Thursday. All right, so let's get started with our basic trig functions. 6 basic trig functions. I hope you know them well from Math 104. All right. Now, these were sections 4.2, 4.3, and 4.4 in the old Larson textbooks. I just sort of blended all those sections together. We're going to talk about trig functions, their values, and related identities. So a lot to do in these 3 bulk sections. All right, so we're going to consider 2 general approaches to these basic trig functions. The right triangle approach, which is really great for your basic quadrant 1 angles, and the unit circle approach, which is a good general approach and also really essential for the quadrantal angles, things like 0, pi/2 radians, pi radians, and so forth. Things like the perpendicular lines and straight lines, the kinds of angles you get from those. Okay, now the right triangle approach. Here is the setup. So let's say that we care about this angle theta. And let's assume for now, for the time being, that theta is acute. So we're going to focus on acute angles for right now, and we'll extend these ideas later on. Observe that the 2 acute angles of a right triangle are complementary. These add up to 90 degrees. We have 180 degrees total in the triangle, 90 degrees taken up by the right angle over here in this right triangle, and the remaining 90 degrees will be split up between these 2 complementary angles. We're going to look at one of these. And make sure that you clearly indicate which angle you're talking about. I want to know that you're talking about this angle, for example, as opposed to this one. Okay, so relative to this angle, labeled theta, this here is the opposite side. It's the side that this angle faces. It's the opposing side. The angle itself consists of these 2 line segments. They consist of these 2 line segments connected at this common point. The adjacent side is one of the legs of the right triangle. The 2 legs are perpendicular to each other on the right triangle. The hypotenuse is the longest side of the right triangle. So relative to this angle theta, we can identify an opposite side and an adjacent side. Regardless of which angle you're talking about, the hypotenuse will always be the longest side, and it's always going to face the right angle. Only right triangles will have a hypotenuse. The hypotenuse always faces the right angle, and it is always the longest side. The hypotenuse will always be longer than each of these 2 legs. And by the way, when I refer to a leg or a hypotenuse or a side in general, I may be referring to the actual geometric figure or to the length of that figure. So understand the context. So once again, the other 2 sides are the legs. The opposite side faces the angle. The adjacent side sort of makes up the angle, together with the hypotenuse. Remember, we're not focusing on this right angle here. We're focusing on one of these 2 acute angles that are complementary. Okay. Now, let's talk about the ancient curse, Sohcahtoa. Many of you have seen this, many others haven't, but it's really convenient to know this. It's a nice, convenient way of remembering how to develop these ratios for the sine, the cosine, and the tangent of this angle theta. And again, sine, cosine, and tangent are going to correspond to ratios of these side lengths. And we're going to use ratios of side lengths to define these 6 basic trig functions, at least in the case where theta is acute. We'll generalize it later on. Sohcahtoa. What does that stand for? All right. So the sine of theta, again, it's nice to put parentheses. The sine of theta is the length of the opposite side over the length of the hypotenuse. I'll put that in, let's see, blue here. All right. So the sine of theta is given by basically opposite over hypotenuse. Opposite over hypotenuse. It's the ratio of these side lengths. And observe that this value can never be greater than 1 because the hypotenuse will always be the longest side of the right triangle. In particular, it will be always longer than the opposite side. So notice this will never be greater than 1. And for an acute angle, it will be somewhere strictly between 0 and 1. Okay, now what about cosine of theta? I'll erase these marks over here. Cosine of theta. The cosine of theta, ca, is given by adjacent over hypotenuse. So remember was, okay, so was telling us that sine of theta was opposite over hypotenuse. Ca is now telling us that cosine of theta is adjacent over hypotenuse. The adjacent side over the hypotenuse. The ratio of these lengths. Again, it's not going to be any greater than 1, and for an acute angle, it'll be strictly between 0 and 1. It goes Sohcahtoa. If you say toe, then you might not know if it's T-O-H or T-O-A. So I like to say toa. Sohcahtoa. Tangent of theta is given by opposite over adjacent. Opposite over adjacent. Now bear in mind, unlike sine and cosine, this ratio could be greater than 1. It's quite possible that the opposite side is longer than the adjacent side. So tangent of theta is going to have a different range. In fact, in the end, it will have all real numbers as its range for various values of theta. All right, so we can use this ancient curse, Sohcahtoa, to describe how we can define the sine, the cosine, and the tangent of theta as ratios of side lengths. Sohcahtoa. So, sine is opposite over hypotenuse. Ca, cosine is adjacent over hypotenuse. Toa, tangent of theta is opposite over adjacent. So these are our 3 basic trig functions in terms of theta. We're going to look at their 3 partner reciprocal functions in the next video.